Good morning, one and all joined here. The Department of Computer Science and Application, SRM Institute of Science and Technology, is organizing 2 weeks international virtual professional development program on data science, a revelation of the modern digital era. I welcome you all for this function. I now cordially invite our dynamic head of the department, Vice Principal Admin, Dr. J. Dileepan, to present the welcome address and welcome the gathering. Please, sir.
Thank you, sir. A very warm good morning to all. I extend a cordial welcome to you all to the day 10th of this 2 weeks online international PDP program. First, I would like to extend my hearty welcome to our chief guest, Mr. K. Rajasekhar sir, ex-Deputy Director General, National Information Center, India. Your presence makes us very happy, sir. Thank you for joining us today. I am very happy to welcome all the participants and event coordinators and faculty members to this wonderful session. The topic of today's session is applications of AI and ML in healthcare and medical care. As you are aware that AI is paving the way of new ways to enhance people's lives in all across the world, from business to healthcare and healthcare to education. And it has the capacity to surpass the human doctors and help them detect, predict, and diagnose various diseases more accurately and at a faster rate. And another technologies like machine learning, deep learning, and natural language processing enable healthcare stakeholders and medical professionals to identify healthcare needs and solutions faster than more accuracy, using data patterns to make informed medical or business decisions quickly. So today's guest has very vast knowledge and experience in this area. So I hope this session will be a eye-opening session to you all, and you will get new ideas and skills from the today's session. So once again, I welcome you all to this wonderful session. Thank you.
Thank you, sir, for presenting a wonderful welcome address. Now it's my privilege to introduce the guest of today's function. Dr. K. Rajasekhar is a well-wisher of our institution. He has led several organizations in the ICT sector and architected innovative, cost-effective, and secure solutions to achieve their objectives at NIC, National Informatics Center, MEITY, Government of India. He has functioned as head of Meghalaya, Andhra Pradesh, Telangana, besides chairman of Project Advisory Committee NIC for Techno-Economic Evolution of all major NIC projects in the country. Coming back to his awards, he has won more than 50 national and international awards for devising innovative e-governance solutions in nearly 50 sectors of socio-economic development. The awards include 4 National E-Governance Award by the Department of Administrative Reforms and Public Grievances, Government of India. He is the only technocrat to receive twice the Digital Transformation Leadership Award, CEBIT. It is a German forum. Sir, it is indeed a great pleasure for us to know that you are the only technocrat to receive this award. Coming back to the articles published, he has authored and published over 30 research articles in the national and international journals, including IEEE, Springer, Business Technical Forum. Coming back to his education, he holds PhD, MTech in Computer Science and Engineering, MSc Technology, and MBA, besides various courses at KDE School of Public Management, Seoul, South Korea, Indian Institute of Management, Kolkata, IIM Indore, ISRC Dehradun. He is qualified in UGC, CSIRNet, ISO quality auditing, etc. With this small introduction, it is my privilege to welcome the chief guest of today's function, Dr. K. Rajashekar, to take over the session. Sir, please, sir, now the forum is yours.
Yeah, good morning, and I thank Dr. Dileepan and also the SRM Institute and management and faculty and students for giving me this opportunity. And now today we are actually going to discuss about the applications of AI and ML in the healthcare sector, health and medical sector. So I'll just give a brief introduction and also AI technologies and especially the digital health and machine learning, deep learning, applications of machine learning and deep learning, and AI governance. These are the topics which I'm going to cover today. And after that, any other point you wish to discuss, I'll be very happy to discuss also. So the application areas of AI in health sector, if we have seen, actually this is a slightly old slide, but neoplasm. These are the areas a lot of applications were actually AI research has been done, and in the nervous system, cardiovascular diseases, and urogenetical diseases, pregnancy, digestive, respiratory, skin, endocrine, and nutritional. Apart from that, the recent, this is a 2016 slide, and in the past 6 years, a lot of applications have been done in the respiratory. A lot of improvement has a lot of applications have been developed, AI based and post-COVID, and also in the area of ophthalmology and also cancer. So those applications also I will discuss. Apart from that, optimization of the healthcare resources. In those areas also a lot of research has been done. And in the medical records, electronic health records preservation, translation or transcription and storage and retrieval. In these areas also a lot of AI research has been done and applications are also developed. AI technologies which are actually being used in the healthcare sector are typically the support vector mission for classification of the objects or the health records, and neural networks, logistic regression, discriminant analysis, random forest regression, linear regression, naive-Bayes analysis, nearest neighborhood analysis, decision trees, hidden Markov models, and others. So these are the popular AI technology being used. And the big data which is coming in the healthcare sector can be categorized into the diagnostic imaging. That is the data, majority of the data, around 60 to 70% of the data is coming from the diagnostic imaging. And electrodiagnosis, genetic diagnosis, clinical laboratory information, and so these are all other mass screening and others. So those are around 30% of the data is coming from that area. But now IoT devices and wearable systems are also contributing in a big way, but they belongs to one of these electrodiagnosis. And diagnostic imaging, that is IMR, ECG, or NMR, or other scanning, whatever 2D echo scanning, or whatever scanning is happening. These are all the major portion of the medical data which is actually coming in, and as a result, actually there are pros and cons of it. And we see wherever there these diagnostic centers are there, especially the scanning centers are there, the gender ratio is falling. So though the hospitals or the diagnostic centers or those radiologists have to comply to the PCPNDT Act, that is, they should not reveal the gender of the womb, but still they devise different methodologies to reveal the womb, and also they charge heavy price for that. And like if they sign with a red color pen something, it will indicate. If they write with the blue color pen, so the color of the signature will indicate. Or if they tell, if you come and collect the report on so and so date, that means on Monday means it conveys male, and Tuesday means female. Like this, they have without being detected by the law, they are trying to reveal the gender. As a result, wherever the diagnostic centers are there, the gender ratio has fallen. And in the recent years, there are some efforts for improving that. So these are some of the AI technologies. Some of the networks and some of the latest technologies which are being used in the medical field are recurring neural networks, convolutional networks, deep neural networks, and deep belief networks. So these are the artificial neural networks predominantly used in the AI for the deep learning and machine learning for application of AI in the medical and health sector. So all this is becoming possible because of the digital health or M-health. So physician use of mobile technology to 250% more likely to own a tablet than any other consumer. So nowadays, 66% of the doctors or healthcare professionals are using in the developed countries a tablet PC. And in India also, there is an organization, FHI, that is Family Health in India. So that organization also has come out with a tablet PC. This tablet PC, with additionally, we can connect some gadgets, IoT-based gadgets. So it can actually diagnose or perform 100 tests, like ECG or blood test or sugar. So many 100 tests can be done with that tablet PC. So that is being given to on pilot basis for field level health workers. So that way, US physician smartphone adoption is 85%. So they are using smartphones, and the patients are also nowadays using smartphones for personal care or for some other self-care or for getting in getting in touch with the medical professionals. Patient use of mobile technology also is increasing. 13% having access to and transmitted personal health information or records in the past year. And during pandemic, these figures have increased enormously. 52% say they would like to access the tools or a website that enable them to review quality rankings, satisfaction rankings, and patient reviews are for specific doctors and hospitals. So for ranking or for somebody might have been diagnosed and they must have been told, okay, you are now undergo some operation, let us say knee operation. So which doctor or which surgeon can do the job better, so that minimum invasive. Nowadays, they're actually also advertising in a big way the hospitals about robotic surgery, so that this robotic surgery has become a selling point for the doctors, and so they're actually advertising in a big way the advantages of the robotic surgeries, and patients are now getting confused. So even a junior doctor also who may not have much experience, also if they have procured a robotic surgery equipment, then they advertise, okay, our hospital is equipped with so and so, so and so, so and so. So these are some of the points. So these are this way the hem health and also digital health, patients and the healthcare professionals as well as the paramedical staff, everybody is using in a big way the digital devices, tablet PCs or cloud computing devices or mobiles. As a result, a lot of information is in the digital form in the health sector is coming in. And the imageology, this is also another big, and as we have discussed, the diagnostic, most of the diagnosis is now being done by scanning. So if we say some pain, then say they are also asking high resolution scanning of that particular part. So blindly they are asking for such type of images, and as a result, these images also are coming in a big way. And teleradiology also now is teleradiology. That means a radiologist need not be there in every diagnostic center or every scanning center, and there can be one radiologist may be there in a city like Delhi or in the AIMS or in some place or in Chennai, and all in the districts or in the rural areas, the diagnostic centers need not have a radiologist. They do the scanning and they send the images digital, because most of the equipment nowadays are providing digital output. So this digital output can be sent, and the specialist radiologists at Chennai, they do the analysis and they give the uh, analysis result of the images they give, and that will be given to the patient. So this how actually it is happening. All the networks of this diagnostic centers nowadays, they are not keeping any radiologists at every center. So this is how actually, as a result, more and more centers without having a radiologist are able to also they tie with a radiologist remote who may be located remotely in a big city, and they provide the services. So as a result, they actually these diagnostic centers are increasing, and irrespective of the number of whether the number of radiologists are increasing or not. So because the increasing number of radiologists is an issue, because the seats have to be increased, and for radiology the seat means it has a high demand also, and we don't have that many colleges also. But still, this teleradiology is facilitating the growth of the image, a lot of digital data of the scan data, X-ray or MMR, IMR, or whatever maybe, all other type of data. So all this is contributing, all these digital gadgets and this equipment, they're actually contributing to the digital health, and for examination and patient generated health data or laboratory results or medical imaging or inpatient monitoring. So inpatient monitoring also nowadays is happening in a big way through the IoT gadgets and devices. And so AI in healthcare, all the typical application areas of AI in healthcare are clinical decision support, and safeguarding the clinical trials, and workflow implement in the health center or in the hospital, and inpatient alerting, and fraud prevention also. And for example, this in a big way, there is a lot of scope for application of this AI in fraud prevention, and also for auditing the medical records or auditing the decisions. Because most of the times what is actually happening is because of the privatization of the healthcare and corporatization, there is a tendency for the hospitals to generate more revenue, and also ensure occupancy of the ICU beds as well as the CSU beds, or the occupancy of their operation theater, so as to generate more revenue. Because a normal bed is less costlier than a CSU bed, and the ICU bed is so. This way, they always ensure, they wish to ensure occupancy of this operation theater beds, CSU beds. So that is one of the objective, and as a result, they try to also give some advices, so which are actually are required to be audited. So that way, right now we don't have such a mechanism, but with the advent of this National Health Authority, the government of India is trying to create a repository of the health records, and which may pave way. Right now, that is not the objective, but which may pave way for auditing of the medical records, and also the decisions of the specialists. So whether such a particular procedure, which is a costly procedure, whether it is required or not, or whether so this type of research has to happen. Only well-educated patients are able to take a second opinion, and also are able to go for a well-informed decisions. Otherwise, a majority of the patients are actually going by whatever the doctor they get admitted to hospital, and whatever they say, they just go by that their advice. So there is a lot of scope is there for application of AI for fraud prevention in the diagnosis or in the procedures or in the medical decisions, as well as in the billing also. Because the billing, sometimes the insurance companies, if there are there, and so the billing or the generation of the bill, processing of the bill, or the payments. So a lot of scope is there in application of AI there in fraud prevention. And population health management also, there is a lot of scope for application of the AI. And patient profiling, this is also important, so that patient profiling facilitates capturing of the information of the patient right from the childhood, so that the diagnosis or investigations takes less time. Because whenever we are actually going to a doctor or specialist nowadays, what they say is, you undergo this test. So they prescribe a lot of tests and those investigations. And because the doctor wish to take a carefully, they wish to take a proper decision to arrive at the decision, and they prescribe a suite of tests. So in case if the medical health record is available to the doctor, then he can take a confidently a decision and diagnose and start the treatment quickly without prescribing several tests. So that patient profiling is also going to be helpful. But in case if a patient is moving from one health center to another health center, or from one hospital to another hospital, or one consultant to another consultant, the interoperability of the medical records, exchange of the records, so such a system has to be there in place. So this is possible only when a national level health repository is available. So with the establishment of the National Health Authority in the country, the objective of the government of India is to facilitate storage of the medical records of all the citizens in the country, and also to ensure interoperability, for which they have also coming out with the standards. So the standards are also very much important to ensure interoperability. There are HL7 and other such standards are there. We'll discuss that also in future. And for imaging also, there are DICOM standards are there for every for tag. So we need to comply with the standards. And when we are actually also advocating in India, the prescriptions are to be in the local language. Because if you say, for example, the population of France may be less than Tamil Nadu, and but the doctors, they prescribe in France, in French language only, the medical the prescriptions. So similarly, in general, so in the Europe, those countries are small, and their population is very less, but still they use their native language. Whereas in India, all the doctors, though they may be their native language, so their mother tongue may be Tamil, and the patient also may be speaking Tamil only. He may not be able to read and write other languages, but still the prescription is in English. So the standards are to be there to prescribe medicine. The prescriptions are to be in the local language, so that apart from English, let them also write prescriptions in local language. And because all over the world it is happening like that. If you go to Middle East, they prescribe in that Arabic language or whatever language the country prescribes. So those are all monolinguals. Whereas in India, these big MNCs and doctors, they are only using only English. So now we need to ensure medical records in local language. Once we are actually enforce or when they start writing medical records in local languages, then the AI tools are required for detecting this language, because English, a lot of research has been done in local languages also, local language computing and local language detection, and also passing the records, and also classification of the records. So local language AI requirement is also, scope is there for AI specialists, in those who have knowledge of the AI, knowledge of the local languages, can also contribute and do research, so that others cannot do, and only in India that can, our own native language people can only do. So that is going to be very much helpful for our Indian population. And social media magic forecast disease outbreaks. This is also another typical example of earlier for predicting the disease outbreaks. It used to take 4 weeks because onset of the disease and then collection of the data from the primary health centers and secondary health centers, and collation of this data through the even high-speed internet networks, and it is to take at least at least 2 weeks time to predict the outbreak of any communicable diseases because collection of this data is a time-consuming process even through the digital means. But nowadays, with the advent of this social media, because social media charts are being analyzed through PyTorch and other such AI tools, and by the social media communications, somebody is talking about, okay, I got a cholera, or I got flu, or I went for diagnosis, or so this way the tags of this communicable disease actually are being passed and detected, and we are able to successfully predict uh, much before. That means 2 weeks before the actual prediction based on the data, field data, the real-time data collected from the field, from the diagnostic centers, and also from the hospitals. So the social media network, it has also analysis has proven that for early prediction of the outbreaks of the diseases in any particular area, the social media data can be used in a big way. So this unstructured data, though it is unstructured, but it provides faster feed so that so particular area is some disease outbreak is going to be there. Then preventive measures can be taken by the population in the neighborhood, and they can start taking preventive measures. So this way, AI can help in reducing the morbidity of the population, so as they can take preventive measures even before the onset of the diseases, because as and when any seasonal diseases or such communicable diseases usually occur, so we should be able to take care of our own ourselves and our so that the morbidity, once it comes down, then it can also uh, reduce in the expenditure also. Challenges in healthcare data analytics are ever-changing evidence-based medicine, and so that is mixed data and emerging regulatory requirements. So see, these are the important things which one has to take into consideration while applying the AI in the health and medical sector. So ever-changing evidence-based medicine. So this evidence-based medicine is nowadays actually they increasingly more and more tests are being prescribed, and as research and development, more and more research and development is taking place. So doctors have started prescribing more and more tests, and based on the test or test values, they wish to diagnose. So it is evidence-based. A foolproof mechanism is getting evolved. As a result, things are becoming more and more, of course, expensive, but at the same time, more and more, a lot of development also is taking place. That is giving rise to a lot of additional medical records also. That additional medical records facilitates us to come out with more and more knowledge can be discovered for diagnosis, early diagnosis, or for treatment of the disease also. And another important thing is the type of data is very much mixed. So even the type of data, some are images, some are structured data, some are unstructured data, and this type of diagnosis is also very much different. There is no standard pattern in which the reports are getting generated. So some may fall within a range, some may be textual content, some may be numeric, some may be so. Different types of data also are coming, and apart from that, audiovisual content. So this way, it is a complex data and also emergency regulatory requirements. So another important thing is the regulatory requirements, which are not there at present, but more and more regulatory requirements in other countries are actually there. And in India also, there is going to be this Privacy Act is going to be enacted shortly. Apart from that, In the medical sector also, there are Ministry of Health and Family Welfare is prescribing some standard for storage as well as for diagnosis. And in case of the insurance companies and also those who are reimbursing the medical bills, they have their own prescription standards and rules and regulations. So this regulatory compliance also is very much important for while generating the bills. So bill has to be generated as per the standards and also as per the prescriptions of the standards. So the use of digital technologies and in data in the medical life cycle, in the medicine life cycle, just wish to present here. So discovering the new medicines and for developing medicines with patients and for making this and distributing the medicines. Lot of digital health is driving the innovation. As we can see during the pandemic, earlier vaccine, innovating a vaccine and also performing the trials and releasing the vaccine used to take around 8 to 10 years. During the pandemic, within a year, all the at least not one company, at least 3-4 companies, including 1 or 2 companies in India, we are able to discover a vaccine and also release the vaccine. So this has become possible with the AI and ML application of AI and ML in a big way, and developing medicines with patients. So this customized medicines, usually in US that actually happens. They don't. It cannot be a generic prescription. A patient-specific prescription is also very much important because that is very much important. Otherwise, whatever is available for mass production, that may not be, all the chemicals composition may not be suitable for a particular patient, because constitution of the body of each human being is different. And so these mass produced medicines are not that good as and not that safe also. So to develop patient specific medicines is a costly affair, but AI and ML can help in developing medicines which are patient specific based on the medical and health conditions of the patient, and based on his constitution also, and based on his health profile. So that is going to be possible and feasible. So the cost of medication is going to be less. That means because side effects are going to be less to the large extent. So that is going to be feasible and possible, and supporting the medicine in use, and and also for making distribution of the medicine. For example, for the distribution of the medicines also, in the case of, let's say, vaccine, when vaccine has been distributed to the entire country, the logistics have been the logistics have been worked out in such a way, and AI and ML helps IoT devices also. These developments have helped in a big way, because vaccine has to be preserved at a particular temperature below 5 to 6 degrees temperature. If the temperature increases, and then efficacy of the vaccine is of no use. So with a lot of efforts, research, and with the vaccine might have been manufactured and made it available and to a particular state or district administration, but ultimately during the transportation or for while storing and while at any point of time, if the temperature increases, then it is going to be ineffective. So IoT based thermal sensors are being used to sense the temperature in real time, and also preserve the medicines and vaccines at that particular temperature. And that can be monitored also remotely by technologies now available and for the medical and health administration in the country. Technology is now available, so making and distributing the medicines, and in case if the temperature crosses, it can generate an alert. So that way it has helped. That way the AI has come. IoT technologies and AI technologies are able to facilitate safe distribution of the medicines and ensuring efficacy of the medicines. Apart from that, supporting the medicine in use. So that means after prescription, the patient may not take the medicines as per the schedule prescribed by the practitioner. So a app can generate an alert so that the attendant or the patient himself or herself can take medicines as per the schedule prescribed. And in case if they wish to have some guidelines, also the multimedia based apps are also there, which can also talk to the patient and also can, because now music systems, we are able to talk to the music system. Similarly, the app also using natural language processing. If they have any doubt, they can speak, and the app can answer. So for medicine use after prescription, after coming home, or that these are some of the developments. Monitoring the medicine and the patient support, so that is also possible. Empowering patient to manage their disease with continuous feedback and communication. So enhancing reporting and recognition of the side effects. So during this pandemic, this telemedicine has been used in a big way. So patients can monitor themselves, and that too without intervention of a human expert. The systems can see that log the records, and only when it crosses a threshold value, then only alerts can go to the experts. So these are some of the applications of digital technologies, which is giving rise to the growth of data, as well as the growing data is growing. To discover knowledge out of it, AI techniques and ML techniques are essential. So to contribute to the growth, these wearable devices are coming in a big way, are being manufactured and distributed and being used in a big way. So smart watches or skin patches or internal measure units or headbands or mobile tablet applications or biomedical shoe insoles and smart garments and eyewear or assess sleep and wakefulness. So these are the wearable devices from the toes to the head, everywhere we can wear, and they can actually continuously monitor the heart rate or blood oxygen levels or breathing rate or muscle electrical activity or stress or emotion, cognitive function, movement patterns, speech analysis, and sleep patterns also. And so these wearable systems are now being increasingly used by sports person, as well as those who are health conscious professionals, as well as the patients continuously. So these are also giving rise to lot of digital data, and the digital data for analysis, and for analysis of the data, lot of machine learning tools are required. And so as we have already discussed, the machine learning is different types of methods are there for machine learning, that as all of you are aware, unsupervised learning or supervised learning or clustering and dimensionality reduction. So where the dimensionality reduction, meaningful compression of the data, and big data visualization, dimensionality result is required for reduction of the multiple dimensions to reduce the complexity of the data, to simplify the data. So to extract the features and also to discover the structure. So dimensionality reductions we do. And so some of the tools are like, and also, and unsupervised learning, clustering, recommender systems, target marketing, customer segmentation. So clustering is another way where we can, it is another method, popular method of unsupervised classification, so that without any input data, it will try to form the clusters. And in the case of supervised learning, regression analysis and classification, these are the methods. So classification for diagnosis or image classification or identity or fraud detection. And in the case of regression, for for predicting the onset of the disease, So for different applications, this regression analysis is used, and there are different methods of regression analysis, which we'll discuss further. And reinforcement learning also, game AI, skill acquisition, learning tasks, robot navigation, and real-time decisions. So this type of reinforcement learning also is popular in the machine learning. And for robotic process automation and for automated processing of the medical bills or automatic transcription of the medical records, this reinforcement learning is used for digitizing the manual records. And the machine learning and deep learning, as you know, input in the case of machine learning, we give the input data and human expert extract the features from it, and then it is further goes for classification. And so whether it is a car, for example, if the input object is a car, whether it is a car or not, so based on the features, so we give the features also and the sample data, then only we'll be able to. So typically that is supervised learning in the machine learning. In the case of deep learning, it is unsupervised learning, and we just give inputs and we don't provide any features, and the system will try to extract the features and it will classify itself, and without any human intervention. So that's how actually this deep learning is. And wherever but in both areas, the system will improve based on the feedback. It will try to improve, and it will try the algorithms improve their performance. So HLC standards to facilitate this deep learning. I think there is some crosstalk or somebody is speaking. Any point? Anybody wish to make any point, please?
No, sir. I think there is a disturbance from the user side. You please thank you.
So they can mute and can speak locally, so that way it will not disturb others. Yes, and yeah, education. So as to facilitate machine learning and deep learning, the data which is being generated by the various diagnostic centers, hospitals, and clinicians and practitioners, they have to write the data as per some standard format. Okay. I think Dr. Revati Madam, mic is unmuted.
I'll mute, sir. Now it is.
So, yeah. So now, so this HL7, health level 7. So these are some of the international standards to preserve the medical records and also for communicating the medical records. So electronic health records, the standards maintenance is very much important, because there are so many diagnostic centers. Some are in the government sector, some are in the private sector, and sometimes the patient may move from one country to another country also. So there should be interoperability of the records, and also the records, whatever our records are there, we should be able to archive the records. And once we are able to archive the records and store the data in a particular standard, then only we'll be able to learn some patterns from this standard. So it will facilitate education and awareness, and also this is a primary standard and foundation standard. Clinical and administrative data, domains data can be stored, and electronic health records profiles also can be stored as per the HLS standards. And it has also contains the implementation guidelines also. And the guidelines references also are there in the HL7. So whenever the communication takes place between a healthcare service provider to another healthcare service provider, or from healthcare service provider to the insurance company, the medical records can be exchanged in this standard format. And there is also facilitates encryption of the data, so that the privacy, confidentiality, security can be ensured. So these are the standards. As healthcare providers have started adopting the standards, there is growth of there is now facility opportunity for us to collect and collate the data. As we are able to collate the data in a big data, we are able to also able to do this machine learning and deep learning. And another important aspect of the development which is facilitating the AI and ML application in the health sector is integrated health enterprise. So as a result, the enterprise architecture is being adopted by the healthcare providers or hospitals. So end to end, from registration to report repository or diagnostic workstation to image archive or 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 examination orders or clinical orders or the all entire hospital, there is entire all the operations are being, all the processes, procedures, services are being digitized. So as a result, and there is a digital ecosystem is existing in the hospitals, especially the tertiary care hospitals and super specialty hospitals. And as a result, this is also giving rise to the existing digitization of the medical records, and also interoperability, and also accumulation of the health records in the standard format. Another important thing is ensuring vendor neutrality of the data what we are actually storing. So that is also important. Vendor neutral archiving of the data. This is another important aspect. So like dental information or nephrology information or orthopedic information or whatever information, most of the time HL7 he will not impose some strict tax. So there is some amount of customization is available. So this vendor neutral archive facility, this is another important procedure or the standard or the protocol which is being conformed to and prescribed, so as to ensure interoperability of the data collected by different vendors or different diagnostic equipments. Another important thing is this IoT-based health monitoring systems are coming in a big way. So whether a patient may be there at home or in a hospital, so sensor data are able to sense the blood pressure or ECG or heart rate or fall detection or oxygen saturation or sleep monitoring or the body temperature. So the vital signs of the body are being captured and monitored continuously. If they're in a hospital, in a few hundred or few 1 or 2 thousand patients may be there, and humanly, of course, the nurses may be there to monitor it manually, but with the wearables equipment or the devices continuously monitoring the healthcare, and only when a particular value crosses a threshold, the IoT and AI-based system will generate an alert to the nearest care providers. So that way, the smart e-health gateways in each room are there, and they will capture the data. And then local medical supervisors and caregivers can actually take action. And in case if the patient is remotely located, they may provide some primary care, as well as they may and alert also goes to the ambulance automatically. So this, without any human intervention, this most 80% of the activities are taking place nowadays in developed countries, and in some parts in our country also, because of the advances in the AI and IoT. So IoT-based health monitoring system is there is a lot of scope for research and application. Health cloud APIs, and on other important thing is actually because of the advent of the cloud technology and containerization and microservices architecture are being increasingly being adopted by all the hospitals. Earlier, we used to have a system on the premises, and when we have installed the system around 20 years back in a hospital, and we used to have a supervisor or the system administrator has to be positioned in the hospital on 24/7 basis, because most of the time the hospitals, because not all the hospitals they work operate on 24/7 basis, especially the secondary and tertiary care hospitals. So keeping a administrator 24/7 at the hospital premises is a costly affair, And that's why we this cloud-based technology, when it has come, it is actually all the instances are being moved to the cloud. With a single central cloud instance, we can actually render services to all the hospitals. So most of the hospitals are nowadays using this cloud infrastructure for storing their instances of the health information systems. And another important thing is application providers like Google or IBM. They have also come out with APIs, health cloud APIs specific to healthcare providers. So we need not develop a lot of software. The programmers can actually call this APIs, and actually they can actually provide services to any hospital or develop applications with less efforts. So that is also another important thing which is giving growth of the digital health and also medical records. So cloud healthcare API, Google has come out with the cloud healthcare API, and also IBM and Amazon, like these companies are actually providing on subscription. We can just subscribe to those APIs, and we can use them, and we can provide services to the hospitals. Cloud, they can publish and subscribe, and cloud storage is also possible. Cloud data flow and cloud data processing and big data query, and so this is another important the cloud technology. Growth in the cloud technology also has contributed in a big way to the health sector. And another important thing is IoT, as I told, IoT and edge computing and fog computing also. These are cloud and fog computing and edge computing are also giving rise to the adoption of IoT-based healthcare systems increasingly in the hospitals. Apart from that, another important thing is during the pandemic, for example, around 77 super specialists have died. They have been immunized twice or 2 times they were vaccinated for COVID. Even then, they were succumbed to the COVID because of the. If we analyze, they say these doctors, they are well aware. They have actually followed all the procedures, COVID protocols, and but still they have died. The reason is they are vaccinated because they are first to do, because government has first vaccinated the healthcare professionals. After that only they started vaccinating the ordinary population, senior citizens, then ordinary population. So in spite of doubly immunized, they are actually fully immunized. Even then they have during the first wave itself, around 77 professionals have died. They're all specialists. And the president of the Cardiology Association also has Mr. Dr. Agarwal. He also has died. The reason is the viral load in the hospitals, especially the specialty hospitals, super specialty hospitals, is much more than in the ordinary places. So they say that whatever vaccination we have taken, it can only take care of normal viral load. And in case if a person is subjected to heavy dosage of the viruses continuously for a longer duration, which are there in the hospitals, as a result, they have died because of that, and the vaccines were ineffective at that high level of exposure to the virus. So that's what. So then another important thing is hospitals are also being sanitized. So the sanitization levels may not be uniform in the entire hospital. And if the doctors or the caregivers are moving in some areas and which are not highly sanitized, and that is also a risky for healthcare providers and apart from the patients also. So the health hospitals, we look forward to hospitals for treatment. But in case if the hospitals are unhealthy places, then it is a big risk. So IoT based AI techniques are being adopted in the developed countries in a big way to ensure this sanitization in the hospitals. And at every location, the bacteria level and virus load in each location in the hospital in the operation theaters or in the diagnostic labs or in the kitchen or in other places or in the wards or every location of the hospital. These IoT devices are there. They measure the temperature, they measure the oxygen level, they measure the viral load continuously, and they create a heat map as and when there is means in case if the viral load is higher, if the sanitization level is lower, then automatically the sanitization sprays and also the UV lights will glow. Of course, UV lights are harmful to the human being. They alert the human being. So the sanitization takes place properly. So AI and ML and IoT has in a big way are contributing to facilitate adoption of the standards in sanitization in the hospitals and safeguarding the healthcare providers in the advanced countries. In India, still that technology and those applications are yet to grow, and lot of scope is there for our AI professionals and our engineers to develop those methods, because IoT devices are there and they can be. We need to sensitize the hospitals to go for such applications, and so that we can safeguard the hospital professionals themselves first, because most of the time they are residing in the hospital. Patient may go for a few hours or sometimes for a few days and come out, but the doctors and caregivers are there in the hospitals, and ensuring their safety, security, and health is much more important. So for that, AI and ML are going to play a vital role, and there are several use cases in advanced countries, and similar things can happen in our country also. And physiological signal processing is another big area where actually the brain networks and brain to heart network also can be monitored, so that and also muscular networks, which we have already discussed about the wearable systems. So wearable systems will also detect about the brain activity and also the brain to the heart activity, so that whether person is sleeping or is awake or is running. So, and what is the normal activity, and if he's in a normal position, if or if there are any abnormalities in his activity, in his day-to-day activities, then systems can generate an alert, and it can actually a treatment can start early. So if a treatment can be started early, they can get cured also much earlier without much problems. And for all these systems, variable systems, which are all generating the digital signals, are required to be processed, and our AI technologists should also be aware of the digital signal processing methods and techniques. Now, for example, this is a Fourier transform, which left side is a Fourier transform, and the typical in the time domain, and in the frequency domain, its transform data is in this form. So the red lettered bar graphs. But this Fourier transform has been developed long back, a century back, and in those days it is much more effective. And with the advent of the computers, digital Fourier transform also are used in a big way for you analyzing the data. But it has its own drawbacks, and now wavelet transform is much more effective in classification or for or detection of the patterns in the medical data. So in the case of wavelet transform, we can, because this Fourier transform, the principle is any signal can be composed, means can be synthesized as a combination of sine and cosine waves. So that is actually the basic principle. But every signal may not be in the every means we will be forced to synthesize or presume that any given signal, any given data is a combination of sine and cosine wave. Whereas it may not be in the real world, it is true. And another important thing is the data has to flow from minus infinity to plus infinity, as per the analog Fourier transform. Whereas that is not also true in the real world scenario. So wavelet transform is another important transform which is actually very much more effective, and we can actually synthesize the data in the form of a box function, or that is HAR function, or Shannon or sync function, or DAB4 or DAB20, or pure flat, because these are different patterns, a signal Gaussian or spline. So we can actually different types of signals can be used to synthesize the input data. So that way wavelet transform gives us much more control and easy to compute also. And so this is being used increasingly for image processing nowadays. And also when you're processing the data, because we have a lot of frameworks in the other earlier lecture once I've given, because all of you are also aware, there are so many frameworks are available for open source frameworks like PyTorch or TensorFlow, or more than dozen 20 frameworks are available, and which are also freely available. And so these frameworks are also facilitates us to process the signals or the digital data using different transforms are also available. Of all the transforms, Fourier transform is popular, but wavelet transform is also very much popular and much more effective, and it can be used for analysis of the digital data and for classification of the data. So this data can be ECG of the heart, the electrode, around 12 electrodes. They usually stick to the chest, and they take the electrical activity of the heart. And normally it has a P, because just if you can see the signal P, Q, R, S, T. So these are the 1, 2, 3, 4. So this is a typical ECG pulse, and a healthy pulse, and it can be analyzed, and the difference between the PR segment and also QRS complex, so Q2R and S2T. So this is the S2T. So Q to T interval. So this for a trained cardiologist, this will give a lot of useful information. And nowadays, digital and low cost ECG missions are also available. And Tata Institute of Fundamental Research has come out with the ECG mission, which is costing digital ECG, which is costing around 5,000 rupees. And they are given franchisee or license for manufacturing for some companies in Kerala as well as Tamil Nadu also. So nowadays, so that way in the rural areas also ECG, portable ECG machines are available. And these ECG machines are also able to generate analog data as well as the digital data. So for analyzing the digital data, we require digital signal processing techniques for machine learning as for detection. For that, wavelet transform, this type of transforms are very much useful. Similarly, the encephalogram data, that is similarly the electrodes are, if they see the activity of the brain, and to detect the tumors or for detecting the strokes or prediction of the strokes, EEG also is being recommended nowadays. So this also generate a lot of signals, and for processing the signals, and also for early detection of the anomalies in these signals, we can use these transforms, and most of these EEG devices nowadays are providing digital output. And for categorization and of this data, for classification of the data, or for learning the patterns from this data, lot of regression methods are there for machine learning and for deep learning. So machine learning, that is, we usually do regression analysis. Regression is association of the data, whatever data, independent data, to the dependent variable, that detecting the relation between the independent and dependent variables. We use regression is one of the statistical method. And in the machine learning, it is being increasingly used. There are different regression analysis methods are there, which we'll just briefly describe now. And linear regression is the relation between the dependent and independent variables is more or less linear in nature, like in a linear curve like this. So then we can say based on this, if we know the data at this point, then in future can be predicted. So if we have data for if as we know the relation, and so we can just say, okay, in case if if a person is able to if he at this particular point of time, and if this is the activity, this is going to the blood pressure. So blood pressure and activity can be monitored. That can be, if it is a linear, then we can, so any two parameters we can actually try to establish a relation in case using this. This is one of the simplest regression analysis method. Another is a logistic regression. In case if the data do not increase linearly like this, in case if it increases exponentially, then logistic regression is used. So that means logarithm of the linear data of the exponential data brings a linear straight line. So logistic regression is used for such type of exponentially increasing data or decreasing data. And polynomial regression is in case if the data is non-linear, and if there are multiple parameters are there, then polynomial regression is used. And ridge regression is in case if the data is non-linear, but at the same time multiple and it varies around a linear line, then ridge regression method is used. And least absolute shrinkage and selection operator is another. Lasso regression is another method where ridge regression, it will try to threshold, it will try to limit the coefficients of the ridge regression so that collinearity can be measured. So that is another method of regression. And quantile regression, there are several collinear lines are there, in not single line like in a linear regression. Then quantile regression is used. And Bayesian regression is another important method to improve the linear regression. Two regression line may be this red colored. Bayesian linear regression is indicated in the blue, which facilitates a little bit more accurate and stable prediction of the data. Decision tree regression is another regression method. Let us say, for example, here over 25 years is the root node, and in case if he is no, then he is not over 25 years, you may use code star. And in case if yes, if he is married, internal node. If yes, married, then he may use a luxury car. Of course, income should also be high. Then no means he may use a sports car. So this is some analogy or some relation which we are trying to establish between the different variables. In case if there are multiple such patterns are there, then we use random forest regression, so that then we can take prediction of all average, or all predictions can be taken. So random forest prediction. So when there are multiple relations and multiple parameters are there, these regression analyses will facilitate us to when the data is varying with the time. The time series analysis is also another important method in the machine learning and deep learning. So we'll be able to forecast and predict for future based on the present and previous data. So that is all time series analysis, which is being used increasingly for prediction of the future health status or health epidemics occurrences in the public health. Introduction to the that is support vector missions. This is actually another method of regression where it will maximize the separation between the classes, the support vector mission. So this is another method. It will try to maximize the separation between the classes. So it will try to increase the gap. Let us say these are the two categories of data. So these are popular regression methods, and for machine learning. And for deep learning, in the machine learning, what we use usually a supervised, mostly it is supervised. That means we give some inputs. In the case of a deep learning, we may not give inputs, and it will try to detect the patterns itself. And multi-layer perceptron is one of the neural network method. It's a popular basic method where information flows in multiple layers, as case of brain. So layer layer input data will be fed to the first layer, and there are activation functions. There are different types of activation functions, and determination of the correct activation function is important for the stresses and for minimizing the error in the prediction. And hidden layers will be there. Information flows from one layer to the next layer. It cannot jump to multiple layers. That is in the linear multi layer perceptron. That is the principle. And the activation function. And this is how a artificial neural network typically is. And we have a lot of frameworks are there nowadays, AI-based frameworks, which facilitates us to use and code this artificial neural networks. And convolutional neural network is another important network, which is improvement of the multi-layer perceptron MLP. And here, usually convolution takes place. Input data, let us say input matrix is there, and input matrix is convolved, and max pooling is selected in the processed output, which is of the intermediate layers, which are selective only, will be flow forward. In the MLP, all the data flows linearly, whatever data. In the case of CNN, all the data will not flow from layer 1 to layer, from layer X to layer X plus 1. So based on the threshold values, the information flows, and the number of layers also can be increased, and activation functions also are changed. So this is another method of deep learning. And these methods are used for different applications, for image classification, or for detection of the patterns, or for natural language processing also. The natural language processing involves lexical analysis, or syntax analysis, or semantic analysis, or discourse analysis, or pragmatic analysis of the spoken data. Spoken data is parsed, and then it analyzes from various angles, from these 5 angles, and it will be able to detect, understand. The machine will be able to understand the spoken language. And so nowadays, for example, some banks have provided this NLP-based interfaces for bots are there for, so that we need not speak, we need not type our questions, and we need not type. We can only speak, and we can interact, and it can analyze, and it can actually react also. And it is natural language processing, as Professor Dulipan has rightly mentioned, is going to play a big role in healthcare, in providing healthcare. For example, at afternoon time, patient can ask what medicine now have to take. So the system will know it is afternoon time, and it will ask whether you have taken meals or not. In case before meals this medicine, before after meals this medicine, and color of the medicine and the name of the medicine also it can speak in local language, the local accent. So that's how actually for in this natural language processing is going to play a major role in to assist the patients as well as the caregivers. And social networks are also so this natural language processing flows. Traffic sources are direct traffic, email instant messaging, and other sources. A lot of social networks, Facebook, Twitter, search engines, Google, Ring, editorial promotions, home pages. See, a lot of data, textual data as well as spoken data is available in the internet, in the social media nowadays. All the data can be actually parsed, and it can be some useful patterns can be detected. For example, as I have shown in the initial slide, social media patterns are able to predict even a fortnight ahead the occurrence and occurrence of the different communicable diseases like flu or dengue or whatever maybe in a particular zone. So then this data can be analyzed, and the speech assistants or the NLP based apps can speak, okay, there is a going to be prevalence of the occurrence of this disease, so you start taking these precautionary measures when you're so this way we can actually going to help our citizens and patients in a big way. And for LSTM, I just mentioned this slide because in the time series analysis, this LSTM uh, uh, long short-term memory cell. This LSTM is long short-term memory cell. So these long short-term memory cells are used in the convolutional neural networks, and then LSTM-based activation cells are used, and these are the mathematical functions. These are used basically for time series analysis. For example, in case if we have data for some for the past 1 or 2 years data of occurrence of a particular disease, and from this data we will be able to predict what is going to be the future disease pattern in that particular area. Or in case if a person has getting some strokes at a particular time, or he's falling ill at a particular times, in so based on the previous profile, previous data, health records, we will be able to predict using this type of LSTM convolutional neural networks if such conditions are going to occur, then whether stroke is going to come again or not. So this way we will be able to, it will generate alerts to the family members as well as to the patient as well as to the caregivers. So this time series analysis method of AA, around 92% accuracy we are able to achieve with this LSTM cells, because so that is another method of for time series analysis. LSTM cells are used, and ResNet is another important deep learning network, neural network, and is being used. It could detect the face or objects at a much speeder way in 2012, and it got an award also for image detection in a competition. So this is its typical architecture, and it has different layers, and multi-layers convolution takes place, and object detection happens. So another neural network methodology is the VGG-net is another method. I think Google has devised this, and it has beaten ResNet, and it has actually in detecting the objects and classifying the objects much faster way. Okay. Later, recently, Microsoft has come out with AlexNet, and this is another for detection of objects and diseases. And during the COVID pandemic, AlexNet is being used for detection of the COVID from the X-ray, chest X-ray images. So this is the architecture which was used for the detection of the chest X-rays, because our RT-PCR tests may take some time, few hours of time, and for even sometimes one day also for giving the results. And sometimes there are false positives also are there in the case of typical RC-PCR, RC-PCR, this test of COVID. Whereas this chest X-ray data crowdsourced from 140 countries during the initial stages of the pandemic, and based on the data, the chest X-rays and the results, COVID results, test results of the patients have been collected, and this AlexNet has been trained so as to predict and detect from the chest X-rays the COVID, whether the person is suffering from COVID or not. Okay. Similarly, these are the AlexNet as well as the time series analysis data can be used for predictive modeling. So when a third wave, if it is going to occur, or fourth wave, if it is going to occur, such type of predictions in the media we have seen, and all that is based on the algorithms, AI-based algorithms, as all of you agree, and the accuracy predictions are also, when they say peak is going to occur at the time, more or less at the time only peak has occurred. Especially our IIT Chennai has also given predictions, and also they have come out with some models, GIS-based models, so that GIS data, it means the data is mapped, and spatially we are able to predict the spread of the diseases, occurrence of the diseases. And so this way, the GIS technology, IoT technology, LOT, location of things data. That means IoT devices are having the location information also, that is latitude, longitude, azimuth data also, and time data also, and other information. So this way, the IoT and LOT data and AML data is able to give a lot of information for prediction and for public policy making also. So that way they are able to detect the containment, the zones where the occurrence is more, and they also announce the containment zones, or other measures were taken effectively. Because as a result, our country, which is a much more populous country and democratic country, also we are able to contain the diseases apart from, and by promoting proper measures. So optimization of healthcare resources is another important area for application of the AI. Traditionally, transactional care happens, entire population is sequentially treated and scanned, and that is sequentially same amount of efforts of the healthcare providers, specialists are being paid traditionally. So now, in the case of this A and ML and this digital health systems facilitates us to define and prioritize the patient's population, and high risk complex care patients can be identified who are to be admitted in the ICUs and monitored in the hospitals, and the moderate risk care managers. Based on the early diagnostic reports, we can classify the population into high risk complex core care team and moderate risk team and moderate risk stable, which are those moderate to rising. That means they are moderate, but their risk level is increasing. So that means health condition is deteriorating. So which is changing. That means such type of patients are next in the danger zone. Next, moderate, their risk is there, but they are stable. It is not the condition is not deteriorating. And the low risk, there is some symptom, but risk is less. So rating is around like so. This way, population can be categorized, and the low risk patients can be told to manage self. Or, for example, during pandemic, they say, okay, your health is okay, you have positive has come, but you get self isolated for 5 days and take some minimum medicines, or take proper health, then diet, then you will be all right. So whereas those are complicated people, they have been put in the hospitals, and much more people, complicated patients who are having respiratory problems, and they are being given oxygen beds and some ICU beds. So like this, we have actually, this categorization is possible because of the diagnosis, and now For the low risk and moderate risk patients, the information, they can diagnose themselves and feed the data, and so that the condition is stable or deteriorating can be monitored by the AI devices, and accordingly the proper care can be given with the minimum specialist support and with the minimum caregivers, because our population is huge, and providing care to huge population, paying attention to entire population is not possible and feasible. So this optimization of healthcare resources is possible. That is one of the important area of application of the AI, and it is being increasingly used. And another important thing is now access channel. For example, a particular patient is like his condition is high risk, and so then telemedicine, if he is remotely available, a telemedicine and phone nurse can advise, and they can actually monitor the status, secure messaging also, and home visits can also happen. Remote monitoring are also after monitoring remotely the patient. So these are all becoming possible and feasible. And another important area of optimization of the resources is, as I told about the radiology, so even team-based care model, integrated behavior. So referral management, billing, coding, workflow and design, open advanced access, practice hours. So this way what actually happens is patients, the resources can be scheduled. And so for scheduling optimization, optimally scheduling the resources, either the operation data resources or specialist time, properly, intelligently, the systems can devise AI-based algorithms can devise to which patient the specialist can pay more attention to first, and which patients are to be operated first, and what at what schedule, like this. So staffing and distribution of resources, allocation of the resources, and scheduling the operations, etc., AI based tools can be used so that the resources can be used optimally, and more patients can be serviced. So same thing is actually written here. And this is a another important thing, as we have discussed, electronic health records, HL7 standards are applicable to the lab data, as well as the radiology data, hospital data, patient data, wearable devices, pharmacies, and physicians. All these sources, these are multiple sources. All of them contribute to the health records, and these records are to be maintained as per the standards, so that we will be able to generate the big data, and the analysis is possible. Another important application of the AI nowadays is Google has come out with the DeepMind IDX is the product name of Google, and it has got FDA approval also for prescribing and detection of the uh, eye diseases. So based on the eye scan data, this DeepMind IDX is able to accurately detect the eye diseases as a human expert ophthalmologist do. So FDA has given approval. The IDX, if it is detecting a disease, it is approved as it a human ophthalmologist has given. So this how actually AI has gained maturity, and even official approval also, AI-based tools. This is one example. And patient-centric and personalized care is another important thing, which is not possible nowadays, which is a costly affair. But with the AI tools, we will be able to provide patient-centric personalized care. Either for it is a $450 billion industry nowadays, the drugs, and these drugs are to be customized drugs to suit the needs of the patient and his health conditions and profiles, etc., has to be administered. So nowadays we give the doctors may prescribe a medicine and patient may purchase it, and while purchasing the pharmacist will not give one or two. They give us entire strip, and the patient purchases the entire strip. and he starts consuming, there may be some side effects, it may not be effective, and during again he visits, doctor may prescribe another medicine. So this trial and error process goes on, whereas the AML techniques can be used taking into consideration the health profile and health history of the patient. A customized medicine can be also prescribed, so and even that can also composed by the system. So this way, in US, the step of composition happens. So it is not readily available. The pharmacist there, he prepares and he gives a medicine, customized medicine also. So such type of things are possible, and with this AI techniques and drug designing, drug manufacturing, drug marketing, treatment for rare diseases also, and rare diseases, because for rare diseases, because manufacturers usually manufacture the drugs which are for mass consumption. So few patients may be suffering from rare diseases and medicines may not be available. So for such type of patients also, this AI-based techniques can facilitate pharmacists to compose a suitable medicines. So these are some of the other advantages apart from optimizing the healthcare resources. This is another application of AI and ML. And vaccine discovery is also another important area, and machine learning, and so mass. So this way we have seen we could reduce the time span for drug discovery or vaccine innovation from 10 years to 2 years or 1.5 year only, because of the AI and ML application by all the labs, research labs. And and another important area of application of this AML is the breast cancer detection with 85% accuracy based on the mammograms. So this is all another important application of AI. And if these are the conditions, and in case if there is a tumor, then there is a possibility of breast cancer. And these are mammograms, and based on that, system is able to detect more and more accurately, as if a radiologist does the cancer detection. Usually, cancer cannot be detected in by just. Usually, cancer histopathologist only will, based on histopathology slides, the patterns will be can be detected by trained histopathologists. And sometimes samples are 3-4 slides, 5 slides are made and distributed to 5 different histopathologists, and the average of their prediction is taken and revealed whether it is a carcinogen, there is a malignant or not. But now with this advances in the AI and ML, we are able to detect that in a much faster way, much more confidently. One example is that eye scans, and it has Google's deep, so that think IDX. Another is AI-based mammograms detection of cancer has come up in a big way. And another important thing is with 85% more accuracy from chest scans, they are able to detect the COVID, whether a person is suffering from COVID or not, with more than 85% accuracy just from X-ray, chest X-rays, we are able to detect based on the AML tools. Another thing which has been reported recently is a mobile app based on the voice samples. So you download the mobile app and you speak something, and at different points of time, if the person is speaking, in case if he is suffering from COVID, from voice samples, the app is able to detect a person is suffering from COVID or not. So this is actually facilitates. This is the app self-management. Okay, in case if he is having COVID, then what has to be done, that also app will tell. So this type of things are possible and feasible, so that the patient need not step out. There is no need of inserting a swab in the nose or in the throat, and then sending to a sample, and or taking an X-ray, exposing the body to X-ray is also, the radiation is also harmful to the body. So all that, so non-invasive and non-harmful method of just you speak out, and system will tell it is a person is suffering from COVID or not. And this type of tools are also developed for detecting other respiratory diseases also. And so this way, AI and ML has a lot of scope and for improving the healthcare. And there is now, when so many applications are there, what is important is compliance, ensuring compliance to the standards, and patient safety, quality care, cost containment, trusted analysis, changing payment models. So these are also very much important. So this information governance, healthcare, AI governance is also important, so that fair and impartial result can be given, and robust and reliable data, robust and reliable predictions are to be robust and reliable, and privacy, confidentiality, safety, and security of the patients are to be ensured, and responsibility and accountability have to be fixed and transparent and explainable. And whatever predictions have come, they should be transparent and explainable. And it is not that a tool may give, okay, he has to undergo operation, and operation may cost maybe 1 or 2 lakhs, and patient has to pay that bill. And ultimately, in case if it is proved that operation is not that required, mandatory, then who has to compensate with the patient? Why? And so who will take responsibility? They should not say, because AI, this is the AI tool, and the AI tool is responsible, I am not responsible. Doctor should not say. Somebody should be responsible. So responsibility of the stakeholder have to be defined. So if a tool is there, the tool has to be calibrated, tested, and accepted by the human expert. And the human expert who is accepting should take the responsibility for the predictions. And also this, they have to also test and calibrate. And because most of the times the learnings happen continuously, appropriate samples are to be fed. In case, for example, for giving predictions of the diseases or health or medical decisions, the Indian population or for a particular region's population data has to be fed. And more data, if it is complete data and comprehensive data, if it is fed, and more quantity data, if it is fed, the accuracy of the predictions will be higher and reliability will be higher. And instead, in case if data is collected or reported from some other foreign country and that data is fed, accurate, the predictions for the local population may not be accurate. So the persons who are going to use these tools, the experts, are to take the own the responsibility. So these are the governance issues which are very much important for promotion of AI in the health and healthcare and medical sector. And so once if such care is taken, and it can be used for training the professionals, and also ensuring the wellness of the patients, and for early detection, and for diagnosis, and for confidence and decision making with a higher confidence level, and for patient treatment, and for end of life care, because robots are nowadays used also for end of life care, for training the patients and for help assisting the patients who are so such type of things. Robots are also nowadays being used for providing healthcare. And AI governance in healthcare: fairness, trustworthiness, transparency, accountability, these are all mandatory and important, so that fully informed consent from the patient to use AI has to be obtained. And educating clinicians and patients about the AI is also important. And appropriate and authorized use of patient data is very much important, because because most of the time the patient data is collected and the patient is the owner of the data, and that data should not be misused. And without the permission of the patient, it cannot be transmitted to any other person. For example, nowadays, because of whatever maybe, or let us say we have Aadhaar enabled payment system in the country. So Aadhaar enabled payment system all the bank accounts are now seated with the Aadhaar number, and anybody with the Aadhaar enabled payment system, a person without a credit card, debit card, or internet bank account also will be able to do the transaction. That means he'll be able to, once a fingerprint is taken, for example, capturing the fingerprints of the patients or the iris data of the patient is, for a doctor or caregivers, is not at all a problem. Simply they can capture, and once they capture, they can use that, and getting the account number of the patient also not important, is not a issue. And so account number or Aadhaar number or whatever may be, because so with this and fingerprint or iris, one can transfer the patient the amount in the patient's bank account to some other account. So this type of things are possible because we have such type of Aadhaar enabled payment system is there in the country now, which to empower the bottom of the pyramid. That means people who do not have a credit card or debit card or a mobile wallet or internet bank account, and to empower such type of population during the denomination time, the government of India has introduced this. Now also it is there. So that should not be misused. Recently, a scam has occurred. It was reported in the headlines by Hindu in Andhra Pradesh only. Some persons, a team of criminals have actually taken the biometric data from some sources of the population and use that biometric data, and they have done a trial and error method to get the account numbers, or the account number is also available, and in which bank. So they have done with some efforts, they could get the account data and biometric data, and with this they have actually looted several lakhs of rupees from of the poor citizens. So here, in the case of health professionals, healthcare givers, getting the biometric information, getting some personal information of the patient is very much easy and possible, and they should not misuse to use that data. So governance rules are to be there, and which are absent. And disease modeling is another important area where this AI tools are being increasingly used. So thank you very much. If any suggestions or any questions or points, I'm ready.
Participants, the forum is open for interaction. You can just put your questions in the chat box, or you can directly interact with the chief guest. By the way, we have posted the feedback link. You may please check that. Participants, the forum is open for clarification interaction. Sudha madam?
Yes, sir. Am I audible, sir?
Yes, please.
Yes.
Yeah. Okay.
I now invite Dr. K. Sudha, Assistant Professor MCA, to propose the vote of thanks. Please, madam.
Yeah, thank you, sir. Good morning to everyone. It is a great pleasure to propose vote of thanks on behalf of Department of Computer Science and Applications, SRM Institute of Science and Technology, Ramapuram Campus, Chennai. First of all, I would like to thank our management for providing a great opportunity to conduct an event like this. It is my gratitude to our respective principal, vice principal academic, and vice principal admin for their constant guidance and encouragement. My special thanks to our today's chief guest, Mr. K. Rajasekhar Sir, Director General, National Information Center, for being here with us today and discussed application of AI and ML technology in health and medical sector. Sir presented excellent session and detailed information about artificial intelligence, machine learning, deep learning, digital healthcare, and AI governance. It's a lot more topic. It's not only listed here. And thank you, sir. Thank you for your valuable sessions and spending time with us. I would like to place on record my appreciation and gratitude to all the participants for their active participations. My sincere thanks to the event coordinators, Dr. S. Uma Shankari ma'am and Mrs. Indumati ma'am, for arranging such a useful session to all of us. Thank you all. Thank you once again.
Thank you, madam. Participants, you can complete your feedback. Thank you, sir.
Thank you very
for
much.
joining the. Thank you, sir.
Thank you. Namaste.
Namaste, sir.